Okay, so here is a tutorial about using XLMiner to run a linear regression and to get all those extra little itty bitty bits that you need to make sure your regression's good and answer all these questions. Okay, so what we're going to do, you should have already gone to add-ons and gotten XLMiner. If you haven't done that, go watch that video on how to do it, come back. All right. And we're just going to go to the XLMiner tool pack and we'll go over to start. We'll hit start. A tab will open up over here. And we're going to, so there's lots of things that it can do. Some of them it does well, some of them it doesn't do very well. We're going to hit linear, this one it does do very well. We're going to hit linear regression. And the first thing that you should do just to make sure that it's working correctly, because sometimes XLMiner has bugs. So far this term, it's been running really smoothly for me and I haven't run into anything, but it's worth it. You're just going to hit the Y range. And if the cell that you have highlighted over here pops up, then you know you've done it right. Don't try and enter these in manually. You can, but it usually has a tendency to mess up when you do that because it wants to just take them. Okay. So we're going to go over to the questions, and we still have to answer this first question to be able to run our XLMiner. Who is the explanatory variable and who's the response variable? We have hours spent studying, so that's going to be, and we've got math SAT scores. Since this is in reference to time, this has to be our explanatory variable. So notice that it wants the Y range first and the X range second. So it's actually looking for you to put in the SAT scores first. So I'm going to go over here and notice that I did highlight my label. The main reason I did that is it's going to make things easier to figure out where stuff is when I go to look at my XLMiner. So even though this E10's in there, I'm going to click over here and it automatically changes to my C1 to C21. I'm going to click away from it. I'm going to click off that. I'm going to click on my B. And so there's my X range. I'm going to go in here and input my X range. Remember, these need to be the same. If they're not the same size, it won't run because you need to have your points matching up. I need to tell it, hey, I'm using labels. Don't worry about this. We'll worry about this when we do our hypothesis testing. Then I also want to click residuals because I want it to do the work for me. We could calculate the residuals ourselves. We saw how to do that. We're not going to worry about that. We're just going to have it calculate it for us. Okay, and then notice I left this blank, the output range. This only needs to be one square. It should only be one square. And it can be any square you want on here that's blank. The main thing is that when it outputs down and to the right. So you wouldn't want to say highlight this square because that's going to mess things up. So I'm going to put it just right underneath my questions. I'm going to put it right here. You can put it anywhere you like. So E13. All right, I'm good. There's other stuff. We're not going to worry about all this. You don't need it. You can see what it does. It's a bunch of stuff you're not going to need. All right, summary output. And you can see there's a whole bunch of stuff going on. So let's walk through what all of these are. Notice that right here, there's your correlation coefficient. Here is your little r, and here's your little r squared. These are the correlation coefficient. Very exciting. Oh, we can close this out now. We don't need it. We're done. All right. My standard errors right here. Here's my observations. Let's go ahead and highlight that. Here is our little N, or the sample size. All right, what else do we have? The other things that we have is we actually have the coefficients. It actually spits out the this is why I like it, intercept and hours spent studying. Right here, those are the coefficients for your equation. So I can tell myself, hey, the equation of the trend line is 353.164875 plus 25.32. Oops, shoot, sorry, I put an extra 2 in there. 326.46778 times x. I can even tell myself this. Y hat is equal to. Maybe I will cut and paste. Or maybe I'll put it right there. Oops. There we go. So I actually have my equation hidden right here. How nice of it. All this is going to be important to us later on. Don't worry about it right now. Here's the next thing. Take a look and see what it says. These are those, these are the y hat values. Ooh, not y hay, y hat. These are the y hat values for each observed x, right? Tells you how many observations you have. So these are those predicted values. And then right here, those are the residuals. And remember, the residuals were the observed values minus the predicted values. So it spit out the predicted values for you, and it found the residuals. So I'm going to highlight this for us. These are the residuals. And we want to take, let's see, what should we do? Draw the scatter plot. Again, to draw the scatter plot, just like you did before, you're going to have to highlight and insert chart. Oh, shoot, sorry. You can do that. I'm not going to waste time in the video doing that. But now you can get a more accurate trend line from looking down here at these coefficients, because the trend line that you're going to get on your scatter plot is going to be heavily rounded. Actually, let's do it just to see it. So here we go. We're going to insert chart, turn it into a scatter plot. It used column B. It didn't aggregate. We're happy. We're going to customize. We're going to go to series. We're going to add the trend line. And we're going to change it into use equation. We can even show r squared just to remind ourselves, is this r squared 0.872 matching up with the r squared we have over here of 0.8716? Yep, that's the rounded version. So notice how they rounded out to 25.3 and to 353 when it's much farther out than that. So, hey, trend. The scatter plot's in my way. Sorry. Watch a teacher struggle. There we go. All right. The next thing that we were asked to do is to make sure that wherever we round our trend line to, that it's actually passing through that point x bar, y bar, where x bar is the average of the observed x's and y bar is the average of the observed y's. So let's create that x bar, y bar. And we're going to do that by telling, hey, Google, we want the average of the B column. And we want the, I got to tell it equals average of the C column. And so this is the point it should be passing through, 9.45 and 5.92.5. I, in my other video, did it with this trend line and we didn't quite pass through it. So what I'm going to do is I'm going to say let's go out a couple more significant digits. So let's use the equation y hat, and I don't know if this is going to work or not. Let's try it. 353 point, let's call it 353.2, and we'll say plus 25.326. How far out? It only went out to 3. Let's do 326 times x. All right, so let's try that. So we're going to see when I plug in 9.45, will I get back something close to 592.5. So we're going to say this equals, we're going to do 353.2 plus 25.326 times, and now I'm going to click on that and I'm going to hit that. And so there we go. We're much closer than what I got before. I probably don't have to go out as many significant digits. So maybe we'll round it to 3.3. Or does that overshoot me? Oh, no. Okay. 2.6 gives us a much better. So before when I did it, it was at 592.1. So it was actually much lower. So this is a much better. So this is a much better rounding of our data than our last one was. Okay. Excuse me. Oh, sorry. Let's see. What do we have to do next? So check. Oh, find the correlation coefficient. Is it significant? Right here. There's our correlation coefficient. Is it significant? Yes, it's in the 90s. So yeah, it's a significant correlation. It's also a positive correlation because my R is positive. When you're over here and you're only getting your R squared from here, remember to find R, you're going to have to take the square root of R and then decide if R should be positive or negative. When you do it this way, it just tells you whether or not R is positive or negative, which is nice. What else do we need? We need to find the residuals and make a histogram to decide if we should. So here are the residuals. We're just going to highlight them and say insert a chart and make sure it's not a column chart. You want a histogram. And right now you're like, I don't know if that's normal. So what you want to do is you want to go over to customize and you want to go over to the horizontal axis and you want to make sure that your minimum and your maximum is the same because you want to see it centered around 0. Is it acting normally around 0? So it looks like my biggest number is negative 125. So I'm going to make my minimum negative 125 and my maximum positive 125. And now I'm centered around 0 and I can see that, yes, indeed, my residuals are behaving normally. And that's what I needed to know. If they were behaving normally, then that means that the linear regression is a good fit. I mean, I know that you can eyeball it from the scatter plot, and say, is this a good fit? This is just an extra mathematical way to say, instead of eyeballing it, this is a mathematical way to say, hey, is this a good fit? And so that's what we've done. Oh yeah, well, we have one really huge residual. This is a big residual. Okay, so to figure out, is that residual, this is a huge residual, right? Is this residual an outlier? That's a question that we want to ask ourselves. So the 8th observation, so we're going to go to the 8th observation. Oh, this is this one right here. Let's find out, is it an outlier? So here's the question, right? Is it an outlier? So that outlier one way to find out is we need the, so to do this, we need the SSE to calculate little s, because little s is the standard deviation of the line, right? And so we need that to see, hey, we're going to go 2 standard deviations below and 2 standard deviations above to see if we've captured the data. So we need to find SSE, and it turns out that XLMiner spits out SSE for you. So if we go down here to where it says ANOVA and we see regression and residual, we're going to look right here in the residuals, and we're going to highlight these guys. Color I haven't used. We'll do a nice dark blue. Oh, too dark. All right, a nice blue. And it turns out that that is the SSE. And this, if you look, is n minus 2. And that is what you need to calculate. Those are the 2 pieces that you need to calculate the little s, right? Because little s is the square root of the SSE divided by n minus 2. And what is SSE again? Remember, that is where you take the residuals, you square them, and then you sum them. It's the sum of the squared errors. I know, there's a lot of jargon in stats. It gets a little overwhelming sometimes, which is kind of why it's so nice that we have all these calculators that calculate our stuff for us. So I'm just going to, maybe over here, I'm going to build a little thing, and I'm going to say S is equal to the square root of SSE divided by n minus 2, just to remind myself what I'm doing. All right, and so I'm just telling myself what is S, and now here's S. Maybe I'll center it to tell myself, hey, we're actually calculating S here. And now I'm going to say equals. I need to do the square root first, so SQRT for square root. The square root of the SSE divided by n minus 2. And there is my little s. And I'm going to highlight this for us. So let's do a bright turquoise. Ah, that's nice. Catches the eye. So this bright turquoise, we want this number, and we want to know 2 times s, because we want 2 times s to compare it to all of our residuals. So I'm going to see what cell this is. This is J21. So I'm going to take J21 and bring it down here. Take my residual plot, excuse us. I'm going to bring it over here. What did I say it was? J21. I'm going to remind myself S, and then I'm going to say this is equal to J21. So I just said it was equal to that same plot. And so I'm going to bring that up, and I'm going to highlight it again just so I don't lose it. Oh, that one didn't get, there we go. There's my little s again. So to compare my residuals, this is positive. I'm going to need to make all my residuals positive. So I'm going to tell myself the absolute value of the residuals. And so this is just going to be equal to the ABS, the absolute value of that number. And I'm going to hit enter. To make it look nice, I'm going to come over here and put borders around it. That way we can see. I want that pattern to follow down. I don't want anything fixed. I want it to go down to the next one. So I'm just going to highlight this and double click. Double click. Oh, it's right. It's because it's generated. So instead of double clicking, I have to click and hold and drag. and drag. And that's a tip. If you're working on a laptop, sometimes it's really hard to drag it all the way down. So it's okay if you just drag part of the way. Okay, and you can always check if you're like, I don't know if I did it right. Click on one later on, go up here, and then just make sure, yeah, it's the absolute value of that one over there. Okay, and now I'm going to do S times 2. So I'm going to check for outliers. And to check for outliers, I want to make sure all of these are smaller than 2 times my S. So I'm going to say this is equal to 2 times my S value, and then I'm going to subtract my absolute value. I'm going to say enter. I'm going to show you something. I'm going to bring it down once, and notice that this is definitely less than 2 times my outlier, but for some reason I'm getting a negative number. So we're going to go look, and we see that because I didn't fix my S value in place, it moved down. So what I want to do is, I want to fix that S value in place. So I'm going to go back up to the original, and the way that you fix it in place is you just put a $sign around the letter, so around the H. So $signs on either side of that H, and that will fix that square in place so that when I drag my equation down, it's using that same square for little s. The columns are changing, the I's are changing, and it's allowing me to change down here, but this is staying in place. And because I calculated this column, this one should let me do the double click. There we go. And I can see right here, so positive, 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 I do have a negative. And so we have an outlier. Oops. We have an outlier. And another way to tell that this one is an outlier is that we can see that it's also horizontally very strange. Maybe we could, we can also see that it's horizontally very far away. And if we took that out, you can see in my other video, when we take this out, it significantly changes the value of our slope. So that's another thing that we might write about. So can we delete it though? Can I just take out this observation? So here, we can see right here, I'm going to take it out. So when I take it out, that just changed it a lot. Like I went from 30.5, it changed it to 30.5 when it was originally 25.3. Here it is again, taken out, put back in, taken out, put back in. So you can see how it's changing it quite significantly, which is another way to tell that it's not just an outlier, it's an influencer. And so this is influencing the way it's far away from all the other data, and it's influencing the way the data is being seen. We can't just take it out though. There's someone that we observed that spent 22 hours studying, and that's the score that they got. So you can't just take out an outlier. You can talk about it though. You can talk about the fact that what this probably means is that the range of this function doesn't do much past 15 hours. So it's probably, how many hours is this one? 16. So it's probably good for only maybe 16 or 17 hours. Heck, maybe it's only good for 20 hours, and that after a certain point, it stops being good. You would have to go in and observe more in here to see what's going on. Maybe at 15 hours it stops. And so even this person isn't doing that well on it, or isn't being observed that well on this line, although it seems like they are. But that's the sort of thing that you want to talk about, is that this is clearly showing you that your range is much smaller than what you've observed for this particular data set. I hope that this was informative. I hope that you can go in. Another thing for this, when you're asked to do your homework, and you're asked to round out, this will not round out far enough, and so this is the better way to get your coefficients when you're doing your MyOpenMath homework. Also, plugging it into your calculator. I have some videos on how to run the linear regression on your calculators.